All right, let's take a look at the quiz yourself questions for section 1.2. In quiz yourself 13, we're asked to verify a Goldbach conjecture for 38 and 46. Goldbach made the conjecture that we can write every even integer greater than 2 as the sum of two prime, not necessarily different numbers. So writing the number 38 as the sum of two prime numbers, we could have 1 plus 37, not 3 plus 35, not 5 plus 33, right? 7 plus 31 is 1. I'm not sure. Yeah, I'm not sure if 1 counts as a prime. I don't think so. But 1 plus 37, if it does, is a choice, right? Let's see, for 46, how about 5 plus 41? Just rattling off some others in my brain. Let's see, 13 plus, oh, that's not going to work. Well, we did find 2. If 1 works, which is why I don't think it does, then technically 2 would be the sum of 1 and 1. Just a thought. All right, so in quiz yourself question number 14, we're asked to test the conjecture that if the sum of an integer's digits is divisible by 8, then the integer is divisible by 8. There's similar ones with 3 and 9 that do work. So they're asking us if the one for 8 works. So let's have a number that sums to 8. How about even just the number 26? Right, 26 is 2 times 13, and that's its prime factorization, so not divisible by 8. So our very first try, and we proved that this conjecture does not work for divisibility by 8. In quiz yourself 15, we're asked to look at example 3 and conjecture how many roots there will be if we have 12 branch offices. So as you can see from the chart here, we're talking about branch offices again, right? This time we're talking about routes though. So if we have 0 branch offices, there are no routes, right? If we have 1 branch office, the branch being B, the main office being A, then we'll have 1 route, that being the AB route, right? 1 route. If we have 2 branch offices, that means we could go A, B, N, or A, N, B if we need to visit both branch offices. Those would be the 2 possible routes. If we have a 3rd route we have to visit, then we have 3 times as many routes as we had before, because we're adding this new C route in to the rotation. And if we have a fourth branch to visit, then we multiply 4 times the previous amount, which starts to form a pattern of 4 times 3 times 2 times 1. So if we were to have 9 branches, they say, then it would be 9 times 8 times 7 times 6 times 5 until we get to the 3, 2, 1. So for 12 branches, then we would have 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, and 1 for a total of 479,001,600 possible routes that we could take. We had to visit 12 branch offices. In Quiz Yourself question 16, we're asked to complete the Kin-Kin puzzle in example 5. The Kin-Kin puzzle is like a Sudoku. We're allowed to use the digits 1 through 4 in each row and in each column. But this time the groupings will either sum to a digit, sum to a number, or have the difference of a number. And that number is represented as a superscript in the corner of one of the parts of the shading. The easiest next spot to fill in is the yellow, because you can see we need to sum to the number 10, and we already have a sum of 6. So the only box left, we'll have to enter a 4. Now we know we need a 1 through 4 in each row and a 1 through 4 in each column, which lets us fill these in. Now looking at the shading for the green, we have a sum of 4, and we'll want to sum to 6. That means we need a 2 here so that we have the value 3 plus 2 plus 1, getting us to the value 6. If we use the convention 1 through 4 in each row, 1 through 4 in each column, we can just fill in these other spots. And in order to verify, you'll just check each condition is met. Did we sum to 6 with these two? Yes. Did we sum to 6 with these 3? Yes. Do we have a 1 with this one? They gave it to us, right? Do we have a difference of 3 with these white boxes? Yes. We have a 3 for this 3, so that checks out. We have a difference of 2 in these 2 boxes here. That's true. 3 minus 1 is 2. We know that 4 plus 4 plus 2 is 10. And our last clue is these 2 blue boxes, and they should have a difference of 1. And they do.